This section's 5.5, so in your notes, please write down the title, 5.5, Solving Polynomial Equations. But in order to really be able to solve polynomial equations, we're going to have to review factoring methods. And what kind of factoring methods? From section 4.3, this is from a while back, it's the last chapter. So this is why I didn't print it out for you. You already have this stuff in section 4.3. Right now, I would like you to just copy down the title, and then you could just relax, follow along, and see if you remember all these different factoring methods that we're going to cover. So it says review of factoring. We already know the very first type of factoring that we should always try is the first type of factoring that we learned, which was what? What was the first type of factoring? GCF. Right, Benji? GCF, right? Would anybody like to see an example of that? Or should we just move on because it's so basic? Move on? See it? Okay. Real quick. Look, parenthesis. What's in common in here and here? The 2 and how many x's? X squared. So when you pull out that 2x squared, what would be left? In other words, it's a reverse distributed property. 2x squared times what will get you a 2x to the 7th? X to the 5th. And over here minus what? 3. That's it. Done. That's pulling out the GCF. That's the first type of factoring we learned. That's the first type of factoring you should always try. Now, after that, we learned this method called factoring by grouping. Yay, that was fun. What was it? You had 4 terms. You had this polynomial, x to the 3rd plus x squared plus x plus 1. You're supposed to try pulling out the GCF, but there's nothing in common. But there's x's in common. No, there's not. This last one's not an x. Right? There's no numbers in common, no multiples, no x's. You can't pull out a GCF from the whole thing. So what we're going to do is factoring by grouping, and it's as simple as this. You take the first 2 terms, put them here. The second 2 terms, put them there. We make some space between the first group and the second group. And then you try to pull something out of the first group. What could you pull out right here from the x to the 3rd and x squared?
X squared.
X squared. Got that, Daniel? All right. So once you pull out the x squared, you have an x plus 1 left over. And over here, there's nothing to pull out, but because we're doing factoring by grouping, we're going to forcefully pull out a 1, which doesn't change anything. So we pull out a 1, what's left? An x and a 1. So the next step is to take a step back and see if you have a common binomial, which we do. We have an x plus 1 right there and an x plus 1 right there. So we're going to pull out that common binomial from the first group, pull it out from the second group, pull it out to the front. So these x plus 1s come out here, and the x squared is left over and the 1's left over. So there's our final answer, x plus 1 times x squared plus 1. And that is factoring by grouping. Do we remember that? Yes. I hope so. We learned that in chapter 4. We already tested it. You should be good at it already. Another form of factoring was factoring standard form quadratic trinomials, ax squared plus bx plus c. And the easy method was when your a value was 1. Right? If it just said x squared plus something x plus a number, it was really easy. You would jump right into this factored format of parenthesis with the x and the x, and you simply think what times what is your c value that if you combine together is your b value, and you plug it in right here, and boom, you're done. And you might want to make a list if you need it. Here are some examples. You see all of these have the a value of 1, which means it's really easy. All you do is think what times what is the c value, what times what is 6, that if you combine together is positive 5. What times what is 6 that if you add together is 5? Okay, if I go 6 and 1, that'll give me 6, but if I add 6 and 1, that'll give me 7, and that's not 7, that's 5. 2 and 3. So yeah, you're going to put a 2 right there and a 3 over there. So there it is, 3 and 2. There's your factored form, you're done. That was the easiest type of factoring. If you need to make a list, go ahead and make a list. So I give a couple more examples here, but I think we're all good with that. Even this one right here could be done with that same method. What times what is your c value, negative 81, that if you combine together is your b value, but there is no b value. That would mean 0. So what times what is negative 81, that if you combine together is nothing? Well, that would be a positive 9 and a negative 9. So it's really easy to factor quadratic trinomials when the a value equals 1. It's really easy. Another method is factoring completely. What was that? Well, you try to pull out a GCF. So like if you start with this problem, you pull out a GCF. If you can, you always start with that. On these 3 terms, there is the GCF of 2x. You pull that out, you have this trinomial left over. Factoring completely tells you to look at the inside of the parentheses and see if you could continue factoring. Since I have a standard form quadratic trinomial with the a value 1, I could attempt to put the x's there. And of course, don't forget about the 2x that we already factored out. And think what times what is negative 20 that if you add together is positive 1. And that's how we get a negative 4 and a positive 5. Are we cool with factoring completely? Now, the hard stuff, or the really fun stuff from chapter 4 was factoring a standard form quadratic trinomial, ax squared plus bx plus c, when that a value was not 1. If you have a 2 out there, a 4 out there, a 6 out there, that's where it gets interesting, right? That's where you have to use all these steps. And step 1 is to multiply a times c. Whatever number this is and whatever the number that is, you multiply them together, you get an answer. Step 2 is to think of the multiples of that answer that you got. You make a list. Step 3 is to use that pair of numbers to rewrite your middle term as those 2 other terms from step 2. That way you could get a polynomial 4 terms instead of 3 terms. That way you could factor it by grouping. A lot of people did not like this method. So we did come up with a shortcut. Same first 2 steps, but instead of changing a trinomial to a polynomial, what we do is jump right into the factored form format with ax and ax. And then after that, we magically reduce both binomials by their GCFs. So step 1 is to multiply a times c. What's a times c? Negative 18. All right. Step 2, it says to think of the multiples of that answer of negative 18. Let's make a list. What times what is negative 18? Negative 1 times 18. Negative 2 times? Negative 3 times, negative 4 times, nothing. That's it. There's only 3 possible ways of multiplying numbers together to get that negative 18 besides changing signs. So which pair of numbers, when you combine, gives you a negative 7? That's right. Negative 2 and 9 gives you positive 7. So you have the right number, but you want it to be a negative 7, so you have the wrong sign, which means you have the right numbers, just the wrong signs. So you just switch them to a positive 2 and a negative 9. Okay? So that's the pair of numbers that we want on step 2, positive 2, comma, negative 9. I shouldn't even put a comma. You might think make the mistake thinking it's a coordinate. It's not. It's just those 2 numbers are from step 2. Now step 3, that's where you jump right into your factored form, answer format, binomial times a binomial. And we put ax right here. It says ax right there. What is a though? A is 6. So we're going to put 6x right there and 6x right there. Now, what do we do with these blank areas? Yep. Plug in the positive 2 and the negative 9. The positive 2 and the negative 9 go right in there. So let's put that positive 2 and negative 9 right in there. And now it's time for that 4th magical step. Magically reduce, think GCF of each binomial, if possible. So is there anything in common in this first one? 2. So let's divide the whole thing by 2. Just magically divide it all by 2. What do I get? 3x plus 1. Okay, and the second binomial, is there a GCF? 3. So let's magically reduce that second one by 3. What do I get?
2x minus 3.
All right, and that's it. We're done. That was probably the most fun type of factoring that we had back in chapter 4. Now, we also covered in chapter 4 the difference of 2 squares. You remember perfect square binomials? Mm-hmm. And remember we could take the square root and plug them into our answer format? Now, I should have probably given you this formula, difference of 2 squares, back then, but I didn't. So right now, I would like you to copy it down. Difference of 2 squares. What does it mean, difference? Difference means subtract. When you're subtracting 2 squares, a squared minus a b squared, when you're subtracting 2 squared terms, you could use this formula. Now, the truth is, it's not a good idea to use a formula right here. It's really simple to solve this with any other, square root it, or even think what times what is negative 9, that if I combine together is my middle value b, which there is no b, and you'd be able to factor it easily that way, right? So let's do that. You could either square root it, square root each of them and plug them in, or you could think what times what is negative 9, that if you combine together it gives you nothing. What would it be?
X minus 3.
And x
Plus 3.
There you go. Now everybody should be able to do that. That should be an easy problem. I didn't hear everybody respond. That wasn't good. So on the second one, I could also do the same thing. I could jump right into my answer, square root 25x squared, square root 36, and I will get 5x plus 6, 5x minus 6, right? But I want to take a moment and apply this difference of two squares formula, okay? So how could I apply this formula? Well, you need to identify A and B, okay? So the fact is, I need to rewrite this as something squared minus something squared. I do have 25x squared, but over here I don't have anything squared. So in order for me to apply this formula, I have to rewrite it. So let's rewrite it as something squared minus something squared. So what would have to belong in here in order to, when I square it, get a 25x squared? 5 with an x. And this one's easy. What squared gives you 36? 6. Now, the whole purpose of doing this, of rewriting it like this as something squared and something squared, is so you could clearly see that your A value is 5x, and that you could clearly see your B value is 6. Does that make sense? And then you could just plug it into, here's your formula. Put the A right there, the B right there, the A right there, the B right there, 1's plus, 1's minus. So A right here, B right there, A right here, B right there. Whoops, I should have put 6, not B. There you go, 6. And then 1's plus, 1's minus. Obviously, it's quicker to just say, oh, square root it, get 5x, square root it, get 6, put a plus and a minus, and you're done, right? But if we look at number 3, I hope everybody copied number 3. Up until this point, you don't know how to do that. If you think, well, factor this. Well, I can't pull out an x. There are no x's in both terms. You can't even pull out the multiple of 9. So what are we going to do here? Let's see if we could rewrite this as something squared minus something squared. So let's actually write that right here as something squared minus something squared. Now the whole purpose of this is to just identify our A and our B if we could actually rewrite it this way. So what would have to belong in here in order to get a 49x to the 6th power? 7x to the 3rd. Why? Because a power to a power you multiply. You guys remember that from chapter 4, I think? 4.1. So 7x to the 3rd times 7x to the 3rd, that'll be 49x to the 6th, right? Now how about here? What to the 2nd power will give you a 9y to the 2nd? 3 and a y, okay? So now we've identified our A value. Our A value is going to be 7x to the 3rd. Our B value is going to be 3y. Our A value or B value. So when we plug it in, we're going to have a binomial times a binomial, and it's going to be A plus B, A minus B. We have factored it. So before today, there's no way you could have factored that. There's no GCF. There's no multiple that you could pull out. But now understanding that difference of two squares, if we could rewrite those terms as something squared, then we will be able to apply the difference of two squares formula. All right, guys, we're finally here. New stuff. New stuff. New stuff. Okay, forget it. New stuff. Please copy this down. Factoring with the sum and difference of two cubes formula. Ladies and gentlemen, you will have to memorize the sum of two cubes formula, which is a cubed plus b cubed equals a plus b times a squared minus a times b plus b squared. And then you also have to memorize the difference of two cubes formula, which I'm not going to read because it's really long. But copy it down right now. In a couple of moments, I will give you a strategy on how to memorize these. All right? Copy them down. And copy down those two practice problems while you're at it. So the sum or difference of two cubes formula, doesn't matter which one you're going to write, it's going to be a binomial times a trinomial. Just remember that. It's going to be a binomial times a trinomial. Okay? Down here, when I apply the difference of two cubes, it's going to be a binomial times a trinomial. So right now I'm going to kind of try to get you comfortable in memorizing it. So let's say you wanted to memorize the sum of two cubes formula. It's really easy. That binomial will be the same exact stuff, but without the cubes. Okay, so this binomial is simply going to be this without the cubes. Same thing with the difference of two cubes. The first binomial will simply be this binomial, but without the cubes. Easy, right? And then after that, you have to memorize, first you have the A and it's squared. That's easy because A is the first letter in the alphabet, it's before B. And it's positive. Both of them are positive. If you square anything, you end up with a positive answer. So that's how you could remember that both the A squared and the B squared are positives. And the middle terms are AB. So it's really simple to remember. The only difference is if you started out with the plus, which means you start out with the plus, then this middle term will be a minus. If you started out with the minus, then the middle term will be a plus. And it's that easy. But of course, practice memorizing it. So, do I have a difference of two cubes right here? I have something cubed, but I don't have something cubed yet. So the question is, could I rewrite it? Could I rewrite it as something cubed minus something cubed? Yes. All right, so what is my first something? What's my second something? 2, right? That right there is not part of the formula, but it's essential because that's how you identify what your A value is and what your B value is. Make sense? So the formula itself is a binomial times a trinomial. What's this first binomial? X minus 2. You just take this binomial without the cubes and you put them right in there. So you're going to put X minus 2. That's easy, right? And now on the trinomial part, guys, on the trinomial part, I want you to actually rewrite this, but with parentheses instead of A, instead of B. Kind of like the quadratic formula. You know how we replace the A, B, and the C with parentheses? We're going to do the same right here, so do this, please. Instead of A squared, let's write parentheses squared. Instead of plus AB, we're going to put plus AB as in parentheses, parentheses. And then plus B squared plus parentheses squared. If you do not do this, you're probably going to make a mistake. So please replace your A's and your B's with parentheses. The first binomial, it's easy. You just rewrite it without the cubes. But the trinomial, please replace your A's and your B's with parentheses and then plug in your values. So the A value is X, the A value is X, the B value is 2, the B value is 2. So what's my final answer? We have the binomial X minus 2, and we have X squared plus X times 2, that's 2X, plus 2 squared, which is 4. There's your factored form of this problem up here. So there's no way you could have done that without the difference of two cubes formula. Now, of course, you're supposed to try to continue. Oh, it's a quadratic trinomial. My A value is 1. What times what is 4? That if you add together, it's 2. It doesn't work. So you're done. It's completely factored right there. Let's take a look at number 2. I'm thinking I'm going to apply what formula? The sum of two cubes formula, right? Now, I need to first, because of the plus. And I need to first make sure, identify my A and my B, so I need to make sure that I could actually write it like this. If I cannot write it like this, then I can't really use a formula. So what value in here, when I multiply it with itself 3 times, will give me 8c cubed? 2c. What value in here, when I multiply it with itself 3 times, will give me a 27d to the 6th? Okay, now let's just say you said 9d. Right? If you did say 9, well, what's 9 times 9 times 9 is way bigger than 27, right? So 3, because 3 times 3 times 3 is 27, d to the second, right? Because back in the rules of exponents, power to a power you multiply, 3 times 2 is 6, and 3 to the third, that becomes 27. So that's how you would get 27d to the 6th. So this isn't part of your formula, but it's essential that you do this so you could identify your A value. I probably shouldn't do it like that. You're going to think it's a fraction. Just so you could identify your A value and your B value. That way now you could plug it into your formula. So the formula is going to be what? We know it's a binomial times a trinomial. So I would put some small parentheses for the binomial and some huge parentheses for the trinomial. So what's my first binomial going to be?
2c
2c
plus 3d.
plus 3d. Nice and simple. That's the easiest part, right? Just rewrite your binomial. Oh yeah, with squared, I'm sorry. That's the easiest part. You just rewrite this without the cubes. So it's 2c plus 3d squared. There it is, 2c plus 3d squared. Now over here, please write it again with parentheses, all right? So we know that the first part's going to be a squared. Let's put parentheses squared. And then the middle part, since it started with the plus, the middle part's going to be a minus. And it's going to be a times b. And then at the very end, it's plus b squared. Now, why is it plus? Because anything squared always gives you the answer that's positive, right? And that's just a little trick to remember that your a squared is always positive and your b squared is always positive. Okay, so now let's plug in our a value, which is 2c, and our b value, which is 3d squared. So 2c right here, 2c right here, 3d squared right there, and 3d squared right there. So now the first one, the binomial, it's done. It's 2c plus 3d squared. But the trinomial we could simplify. What is 2c times itself? Come on, guys. 2c times 2c. 4c squared. How about that middle term? We have a negative 2 times 3. What's negative 2 times 3? Negative 6. And then how about the c times d squared? cd squared. And on the last one, what's 3d squared times itself? 3d squared times 3d squared. Positive 9d to the fourth. We are done. I mean, without this formula, you're not going to be able to factor it. Ladies and gentlemen, we're going to stop right there. We reviewed, what did we do so far in this video? We reviewed all of our previous knowledge on factoring. And we also added on the difference of two squares, even though we kind of already knew that. And we also added on the sum and difference of two cubes. For homework tonight, watch this video again, memorize these formulas, and tomorrow we're going to continue right here.